Okay, guys. So I don't know if you've met James before, but he's one of people helping out with coding, and he's currently employed as a data engineer. So, James, if you want to just introduce yourself and tell us a bit about your current role and kind of what are the main responsibilities?
Sure. So I started my current role about, I think it's coming up to 5 months now. I'm a data engineer at a company called CMSPI. It's a financial technology company, but in the niche market of the payments industry. So the data that we deal with is all of the kind of transactional data that's associated with when a customer makes a payment to a merchant. So there might be, when you type your credit card or something in a shop or a hotel, or it could be e-commerce. So like if you make a payment online on a website, all of the different kind of transactions between the different kind of forces at play. That's where we get all of our data, and that's the kind of data that we're dealing with. So I'm a data engineer at this company, and basically what that entails is I manage and build the architecture for the whole ETL process. So that's extract, transform, load. So the extraction process is, where we go and collect all of this data. It comes from various sources, and we put it into like a raw or a landing container in our data lake. The transformation is very varied depending on where we get our data from, and the transformations vary themselves. And we then load that data into kind of different styles of data sets to be pushed towards our analysts who might manage it in Power BI, or they might do specific kind of stored procedures in SQL. So I work on the individual processes involved in all of those ETL, but I also orchestrate the architecture of the actual pipeline.
Awesome. So I imagine there's a lot of data, I'd imagine.
Yeah, so it's roughly 1 billion data points daily.
Wow. Okay.
Yeah.
So how did you kind of find out about that opportunity? Like, how did you end up working for that company?
So I heard about the role from a recruiter. It wasn't one that I applied for directly, but I'd applied for loads of jobs, loads of different recruiting agencies. And obviously, once you do that, they put you on their system, and they learn what skills you have, what tech stacks you're kind of proficient in or aware of. And then whenever they get different jobs that kind of match that kind of tech stack or my skill, they throw those back at you. And so that was one of the jobs that I heard about through them.
Awesome. And so, like, at the role, what's the sort of main technologies you'd be using on a day-to-day basis, would you say?
Sure. So it's all cloud computation, and we do it in the Microsoft Azure framework. So that's all of the orchestration and the pipelining. And then most of the transformation we do in Databricks.
Right. And can you speak a wee bit, like Databricks is very popular, can you speak a wee bit about kind of what Databricks is and why it is you use that technology?
Yeah, so Databricks is built off of Spark essentially, and that whole kind of process of like batch computation and the MapReduce paradigm. Basically, it allows you can store and you can build all of your different like transformation notebooks and perform those transformations on a Spark framework, a PySpark framework. You can also work in pretty much any language you want inside Databricks notebooks as well. And Databricks also has built-in SQL, and it has built-in machine learning structures as well, and also data storage. So you can do quite a lot with Databricks.
Right. Would you say are you purely coding in Python, or have you learned any other languages since joining? Or
yeah, so I'd say 90 or 80% of what I do is Python. But then also I've learned a little bit of Scala, just for, I guess, kind of the convenience and like the different process of thinking that it brings to working with data frames themselves and kind of transforming data frames.
Okay. And so, yeah, I think you just, client signs up. Do they give you the kind of data source that you go grab the data from, or do you have to find that data? Like, what's the kind of process there for you obtaining that data?
So yeah, so it varies. We have three sources of data income really from our clients. The main one is from access to online portals. So those are like provider websites. And by provider, I mean the people who kind of provide the network transaction of that payment. And those are basically just portals that the client gets login access to. They log into them, and then their payments financial reports are uploaded to them either daily or monthly. We then sometimes get secure transfers of files via email, and very, very rarely, but we're kind of keeping our fingers crossed for this, is API access. API access is obviously just a lot simpler and a lot easier to integrate.
That's king, isn't it?
It's not very common for our clients to, allow us to have to, or even have themselves API access to the reports.
Yeah, I think every business these days needs an API.
Yeah,
it seems to be the way it is. Yeah, that's great. So you're also talking about you do use Selenium at some points as well, don't you? You actually use Selenium to scrape some of this data in your job. Yeah. So yeah, how do you go about doing that? Like, what kind of website is that? Scraping it directly from the portal, or is this just other websites that maybe your client wants information on? Or
no, so all of the web scraping that I do is to go and fetch those reports from the portals that our clients have given us access to. And mostly I'll use web requests to navigate through the whole of that portal and download our, their reports using a few different methods there. But sometimes we have to use Selenium because there's certain requests, and generally it comes into the login procedure on one of those portals when you have to authenticate yourself as a user on that portal. Sometimes there's hidden authentication tokens and things like that inside the request, which you can't access directly through the request, and you can only successfully navigate through and get access to the portal or to the reports themselves if you go through an actual browser where it can store your authentication cookies and headers. So Selenium kind of comes in as a last resort when we can't authenticate our scraper using requests.
Right, okay. And can you talk about some of maybe the kind of a cool feature that you've implemented recently, sort of using those technologies or anything like that?
Sure. So I would say it's a cool new feature, maybe, or well, for Databricks, for example, we just implemented CI/CD for those transformation notebooks that we make on Databricks. So awesome. Databricks is basically we create loads of different notebooks, and they're basically Jupyter notebooks. But each one of those is designed to transform the data from the raw state into a readable data frame, whether it be like a CSV or Parquet or just a Pandas data frame. Mm-hmm. So those notebooks are stored in kind of like a directory inside Databricks, and we've just implemented the process of building branches on notebooks themselves so that multiple people can work on different notebooks and also the same notebook, and pull and push to our main production folder of these notebooks without having any kind of conflicts or anything. So that's really important. Mm-hmm. That's really important because all of these notebooks are essentially then triggered inside our Azure Data Factory pipeline architecture. So it's really important that, and we're getting daily data every single day. Those are running every single day, so we can't have any kind of conflicts to updating those notebooks or anything like that.
Right. So you try to like create consistency between the notebooks just so it makes it easier for everyone else, and Yeah, there's no, you can work
Exactly,
efficiently as a team on them essentially.
Exactly, yeah.
Yeah, and just improve them as you go on. Excellent, excellent. Okay, so can you talk about maybe like what's the sort of main differences? Obviously, it's like the big cloud services. You get AWS, you know, you Google, and then you get Google's platform, and then you've got Azure. So, you know, you learned AWS well at AiCore. What would you say is the sort of main differences between that and Azure? Like, if there's any particular tools that stand out that you find better or worse, or what's your thoughts on it?
Yeah, so to my knowledge, Azure, AWS, and Google Cloud Platform pretty much all provide all the same facilities. You know, they all have cloud storage, they all have support for streaming, they have support for their own version of kind of like Databricks access. They can all do their own kind of inbuilt transformations in the pipeline. I think it really just comes down to when a business is building up this infrastructure to deal with data, you know, kind of what framework were they working on before? And I think that's one of the reasons why Microsoft Azure is more common, I think, in businesses, because, you know, more often than not, people, you know, companies are already built on a Microsoft framework in terms of certain technologies that you use. So staying with Microsoft to stay on one kind of payment plan is just kind of
I think easier to sell to someone you've already sold to than so they're kind of used to Microsoft. They're scared of going away from that, I'd imagine.
I would say though, Azure is a lot more user-friendly than AWS. I think it's a lot easier to navigate the different services. Yeah,
so I was going to ask you, like, so obviously you'd use the AWS. Yeah, was it just easy to jump straight into Azure then? Was it not? It didn't take you, there wasn't too much of a ramp up time to get used to that
really,
at all?
it was really quick for me to learn, and really quite obvious where you need to go to find certain things, and all of the different procedures that they give you access to. It's really easy to kind of find information about them and how to connect them all as well.
Okay. So yeah, so you build, all the pipelines are built directly through the cloud. There's nothing running locally, I'd imagine. So yeah, everything's just stored there. Like this. Yeah. And is there any and I take it just like, you know, using AWS Glue, I assume Azure's got a kind of equivalent just to connect these components together. It's pretty seamless, pretty straightforward. Is there anything particular difficulty with?
Sorry, can you repeat that?
I was going to say, is there anything particular you difficulty with, like connecting these components, or you found particularly like a particular error maybe that it took you a while to get past?
No, I wouldn't say so. Like the Azure Data Factory, which is what kind of like where you literally just click and drag different kind of features. You know, it might be a transformation, it might be a Databricks notebook, it could be some kind of like store procedure of an SQL query. The way that you connect all of those different things on Data Factory, which is basically where you build your architecture for your pipeline on Azure, it's literally just click and drag. And so long as you understand how to pass parameters from one procedure to the next and authenticate those procedures correctly, it's really quite easy. And I think I can imagine somewhere down the line there'll be a future where you have data engineers who don't know how to code, because so much of it is just click and drag nowadays.
Yeah, so what you collect the data, what's some common sort of transformations you might apply to it after it's been collected?
Sure. So it depends on the format that the data comes in. More often than not, we can get it in like a CSV file, so like an Excel document. But sometimes we also get data in the form of a PDF. PDF transformations, to be able to transform data from being a PDF document to a data frame, is a nightmare.
That sounds fun.
There's two types of PDF. There's like a text-based PDF. So if you load a text-based PDF with like a certain package, a certain PDF parsing package, then basically what it will do is it'll just read line by line by line by line by line, and it will transfer it all to like one big navigable string. But then you also get image PDF, and basically in order to read in image PDF, you have to have some kind of machine learning trained parsing documentation to actually read text and transfer that back into, read image and transfer that back into a text style. So those are the, PDF is the biggest kind of difficulty in transforming, but then once we have a data frame, a lot of the transformation comes in between cleaning up those different fields. So it might be cleaning up, we get basically the two kinds of data that we get with our data frames are numerical. So like, like numerical data, and then quantitative and qualitative basically. So the quantitative data all needs to be changed into the correct data type. So that there's no trailing zeros or anything like that. And you need to change different currencies maybe, because a lot of it's financial data. But then the qualitative data requires more cleaning, because loads of different kind of artifacts can kind of form during the parsing process, depending on the kind of file that you get. Right,
okay. And how do you deal with that? What's the
regex mainly.
Regex mainly.
Expressions.
Brilliant. Yeah, makes sense. And yeah, so between you and a client, is it more provide, like sort of, do they tell you exactly, we want these fields, we want it cleaned in this way, or do you sort of give them suggestions? Or it's like more of a back and forward sort of thing? Like, how does that process usually go?
Sure. So our clients don't do any of the analysis themselves. We basically provide like a software as a service kind of function. So we take in all of this data from multiple clients, and then we have a few different services. But the main one regarding the cost data that comes from the transactions, that all gets fed into big machine learning model. Don't ask me about that. I don't know anything about that.
Okay. Yeah, well, exactly. Data scientists. Yeah.
That gets fed into a big machine learning model, and basically we then have a product which builds suggestions and analysis, which gets fed into like a Power BI dashboard or something for our clients to then confront. And those dashboards will basically tell them, how can we change how we direct our transactions through payments to optimize how much we're spending on those payments.
Amazing. And you're talking about regex, so do you get any suggestions? And because I don't think there wasn't regex covering the course, so you obviously learned that after the fact. Was that done on the job, or did you go while we were on with AiCore? Did you sort of learn that on the side, or you get advice for how to go about learning regex? Maybe explain a wee bit about what regex basically is.
Yeah. So regex is called regular expressions. Basically, it allows you to, you basically build some kind of pattern of regex specific syntax, which allows you to kind of filter through a navigable string. So if you, for example, maybe you make a web request and you grab all of the HTTP response, but there's only like a little bit of it that you want, or there's like repeat bits that you want, you can build a certain pattern in regex which will filter for all of the different fields that you want to grab. And then you can also, it can also grab them in kind of iterations. So it might have like match 1, match 2, match 3, match 4. And those might be different fields inside your HTTP or whatever navigable string it is. So I didn't learn regex at AiCore. I learned it whilst I was on the job, but it was quite quick to pick up. There's a website called Regex 101 where you can basically experiment with all of your regex patterns and see what the results are going to be. So you don't have to do it inside an IDE. So you can basically paste in a a big clump of text, and then build your string, and it will show you what it's going to grab from that text, depending on how you build your matching pattern. So it's really useful for being able to quickly sort of navigate through different strings and different kind of navigable documents to grab just specific bits. And you can also cut bits out from the middle of it. You know, you can do like string transformation within the pattern itself whilst you're grabbing it.
Yeah. Yeah. So I imagine you use that a hell of a lot if you're cleaning that sort of data, you know, minus the numerical stuff. Yeah. So after cleaning all the data, yeah, it's just stored in whatever. What's the data warehouse for Azure?
Yeah, so there's a few different kinds. You've got they're called data lakes. There's Gen 1 data lake and Gen 2 data lake. Gen 1 is basically a flat warehouse. There's no hierarchy, so you have no kind of like foldering, anything like that. Everything is just dumped into one location. Gen 2 has hierarchical storage. So it's quicker for accessing and, you know, like filtering for certain files. That then becomes a delta lake. The naming gets very confusing with Azure. That then becomes a delta lake once you build on top of that this concept of bronze, silver, and gold data. And bronze, silver, and gold data is basically kind of like the quality of the data at that point in the pipeline. So the bronze is like the raw data that you throw in and you haven't done any transformations to it. The silver is generally where you've cleaned up and transformed all of your data, and the data frame has all of its fields still there together. And then the gold is generally where we'll manifest that into, we put it into a star schema database, but the gold is basically where you then chop that up into, you know, fitting bits of data. So it might be data all related to dates, or data all related to location, or all related to currency, all stored into certain kind of data frames themselves. So the gold is like ready to be read in from a query and fed to Power BI for someone to view there and then. Sorry, I forgot what your original question was. I went in a bit of trouble.
No, that's great. That was great. Yeah, yeah. No, I was just asking about. I was going to touch on the gold, silver, and we've got a very interesting naming convention of silver, gold, and Azure's naming convention of their data frames. Pretty interesting. But no, I was just asking. Yeah, like the size of the database, like where's that stored? I think you covered it there. So you touched on like,
we have a delta lake essentially. So it's a Gen 2 data lake. Where we incorporate bronze, silver, and gold. So it's a delta lake.
Got you. And you touched a wee bit on a star schema database. So there's also like Snowflake as well. Do you want to sort of touch on that and just explain what you mean by that?
Sure. So a star schema is basically you imagine you've got a data frame from, say I download one report or something and build my data frame. In that data frame, I've got loads of quantitative data about transaction costs, maybe quantities, and different kind of fees and stuff like that. But then you've also got different kind of qualitative data that might be like what kind of network that transaction went down. So like what credit cards did that person have when they paid for it? Or what is the merchant code that they paid for with? So, you know, what shop did it go from? What is the location of that shop that it went from? So you have qualitative and quantitative. When you build a star schema, you want to separate out all of your qualitative data, which we call our fact table, from our quantitative data. Sorry, our qualitative data. So the way we build our star schema is we have our fact table, which for a certain report will contain all of the numerical data, but then it will also contain all of the primary keys, which link to all of the kind of sub data frames. So you have your central your central fact table, and then from it you branch off with connecting those with private keys. So this table down here might be anything relating to the date of a transaction. So there'll be a primary date key, and then there'll be, the date, and then in like a string format of what that day was. And then we might have a table relating to the merchants. So there'll be a merchant key, and then we'll branch off to this merchant table, and it will have information about the merchant name, the merchant number, maybe a description of the merchant address. So you kind of, you separate all of your data from one massive data frame into smaller data frames that you can kind of rejoin together whenever you need. Now, a snowflake schema, I believe, then branches off of that. So all of the smaller branches that you have from the star schema, you can then, depending on how complex your data is, you could then branch off of those and have smaller data frames, or more kind of like specified data frames.
Yeah, so it's like this kind of one source of truth, and then you've got all these sub data frames coming off from that, essentially.
Yeah, and there's benefits and there's benefits and drawbacks to both. It kind of just depends on what kind of data you're dealing with and how varied the different fields of the data are.
Mm. And so how do you go about architecting that? Is that something you touch on at all, or is that something you hope to be doing in the future?
Yeah, so every time, for example, if I downloaded it, I set up the ETL process for a new client, and the reports that we were downloading for a new client had qualitative information, which wouldn't kind of categorize into any of the other data frames that we have readily available for our star schema. So I then built a new, we call it like a dimension table. So you have your fact table in the middle, and then your dimension tables are what branch off. So for this specific client in this specific report, I build a new dimension table, which would be able to contain the fields from that data, which are kind of just specifically relevant to that one report and that.
Got you. And so, yeah, why data engineer? Your option, going through the course, you could have went into data science. Like, what was it that really attracted you to being a data engineer, would you say, Jane?
I don't know, because I came from a physics background, so
you could have went either way then.
Yeah, you would have assumed like, data science is in the name. I think data engineering, I'd say it's maybe a bit more coding heavy, but also I think a lot of it is in data engineering, your kind of workflow is a lot more focused on building and kind of finishing off one job, and then moving on to the next, building one product, moving on to the next, building one product, moving on to the next. As a data scientist, a lot of it is of slowly working on fine-tuning the same kind of product that you have built and maintaining that, I think. I don't know why data engineering. It just happened that way personally. I do have an interest in maybe dipping my toes into data science at some point, but yeah, we'll see.
I think data engineering would be a good place to start, for sure. Yeah, and do you interact with data scientists on a regular basis, or is that not something you often do, or you just kind of leave them to make their models and whatever they need to do? Or... Sure.
So I mean, I work in a small team, so I socialize with data scientists. However, I don't really, none of my work kind of flows over into data science at all, and I don't cooperate with the data scientists much at all.
Got you. Okay, and so obviously you're on the AiCore. What did you get most from the AiCore? Would you say that helped you mostly in your job? What was what was the most value for you that helped you in your current role?
I think the most valuable thing was just like the sheer exposure of different technologies and the whole kind of industry framework. you know, because I've gone down the path of data engineering, but, you know, being on the portal, I've always had access to any information regarding data science and machine learning and the technologies there, and also having the community of people from, you know, all of those different fields, being able to build a big picture in my head of the whole industry of just data full stop has been really useful in understanding what people are talking about when they mention new technologies, or being able to kind of extend, you know, one line of thinking from maybe one technology to, you know, these others that I've heard about through AiCore.
Yeah, go ahead.
So I think, yeah, I think just like the sheer kind of frame, you know, how big the expanse of the different modules and stuff, the libraries that they have in teaching.
Yeah, well, I guess it's like knowing the whole data landscape. You know a bit of the machine learning, you get a wee bit of everything, so you kind of understand the overall picture.
And I think that's really important as well, because I mean, I've always felt personally I can't truly learn or do a job on something without understanding why I'm doing it, and having a really big picture of, you know, where is, you know, what technologies is my work going to be fed into, and what technologies could I be using instead of the ones that I'm using here.
Got it. And obviously you've been through the whole, after the AiCore, been through the whole trying a job process, you know, like applying for jobs process. Is there any is there any advice you could give to everyone about what maybe worked for you, what didn't, what you know, what worked the best, really?
Sure. With regards to just straight up getting a job, I'd say apply to get yourself known by recruiting companies. You know, people are kind of like a little bit hit and miss about working with recruiters sometimes, but the more you apply to jobs through recruiting agencies, the more databases all of your, you know, your CV and your education is all going to be stored on. And then it got to a certain point with me where, like, I applied to maybe 100 jobs, you know, 50 of those or 60 of those being easy apply on LinkedIn, literally just clicking the button. It then got to a point where I was just getting phone calls and messages from recruiters just saying, "Hey James, you've got your files in our system. We think that these jobs are going to be suitable for you." And then they just kind of come to you, and you can, you know, you can kind of, you get a lot more exposure to certain jobs that maybe aren't even advertised yet. They've just been promoted to the recruitment agencies. So I'd say work with recruitment agencies, but also really get a big picture for the whole landscape of data as well, because, you know, there's certain technologies that you'll learn at AiCore, but there's loads of technologies that you won't learn at AiCore, like, for example, the cloud computing stuff. And even if we did learn cloud computing, you know, there's a few different frameworks which different companies use. So you're more often than not, I think, going to have to adapt a little bit and learn something new anyway. So become familiar with, you know, what else is out there, and where those different technologies could be used, and how you could get access to learning them.
Yeah, I think, I guess you maybe felt this as well. I think when I took the course, there's definitely a point I reached where I felt quite confident that I could go and learn new technologies. So it was very much like starting to dip my toe into, well, this exists and that exists and people use this, and started playing around with different technologies as well. Yeah, so I totally understand that. And what advice would you give sort of for everyone maybe going through their projects? You get any advice for that at all? Like, what worked for you? Or what to avoid?
Get good at Googling.
That's so good advice.
Yeah, really, honestly, like, more often than not, if you teach yourself how to truly understand, you know, what the error is that you've got, and you really learn how to ask about that error that you're stuck on, and, you know, like, decode an error message inside VS Code and know what to search on the internet in order to get the response that you want. I think that's a really, really useful skill. And, you know, I think most people who work in industry probably spend, you know, maybe a quarter of their time just on Google trying to fix bugs that they don't know how to fix. But getting good at Googling and knowing where to find documentation on different packages and different technologies like that, you can really quite quickly solve problems that just seem really, really hard to solve. And sometimes the answer's just there online for you.
Yeah. Stack Overflow is a great thing. Yeah, so we'll wrap up with questions. Thanks so much for that, James. That was great. So yeah, we'll just leave the room open, guys, for like 10-15 minutes, and if anyone's got any questions, just jump right in. Especially if you're on the web scraper, because James builds web scrapers for a living, so he's probably get some good advice for you. And data engineering, of course. Yeah, man.
So I guess I had a sort of question from sort of my company the other day, because they're sort of paying for my course while I'm here. And obviously I've been sort of letting them know what I've been doing sort of as I've been going along. But one of their questions was, what do I think I can sort of use it for? Because we're a consultancy where we basically sell projects to clients in a way. So I was like, well, I've done this web scraper, or I'm doing this web scraper now. Obviously, I've picked up gaming laptops, but I work within mostly a Braille consultancy. So it was a question from them, where do you think you can use that? And like, I don't know where to sort of start with that question. It's kind of like there's millions of websites out there sort of thing. So I just wanted to know sort of what your opinion on that would be.
So the company that you're working at the minute, what kind of data are you dealing with currently? Are you gathering data, or as a consultancy company to provide any kind of analytics?
Yeah, so I'm mostly in analytics. They didn't really have any data person there at all until sort of I came in. So it's kind of like everything on me. That's sort of why I'm doing the course, because I was very data analytics now. If they've got no one else, then sort of I'll be from start to finish data engineering, data science, data analytics, doing sort of all of it until obviously they get a bit bigger and hire a few more people. But at the minute, it's generally clients coming to us with like a messy, big Excel sheet saying, oh, we have all this data, but we don't have any insights and we don't know what to do with it. Sure. So that's where we are at the minute. But they want sort of the next step up where we start going to clients saying, oh, we now have this within our company. Do you need sort of this service in any way?
Sure. So I suppose maybe what my initial thought would be, like, cross clients. Is there any benefit to you for kind of absorbing data from client to client to client, and for you as a company to have all of that data and build a larger data frame? Is that going to be beneficial for you to be able to provide analytics to any new client out there? You know, the more data that you absorb, are you going to be able to provide more accurate or more kind of perceptive analytics to new clients? And if so, then building the framework to, you know, really absorb loads of data from loads of different places and organize it in a way that allows you to pull interesting insights from that is going to be really, really useful.
Yeah, that's quite similar to a sort of conversation we've been having within the industry for sort of the past year. Is a big thing topic that's been coming up is data trust. Obviously at the minute, rail companies generally keep all their data to themselves and sort of under lock and key. So they're just sort of waiting on sort of hopefully the government to pass something that they have to start releasing data, especially if they end up sort of nationalizing it, because no one really knows what's happening in rail at the minute.
Yeah. So what data do you have access to?
So it's mostly client data. A lot of stuff we do is sort of quality acceptance. So we send people on sites and they're sort of checking over builds of new trains, and they're sort of monitoring any defects, sort of like filling out big spreadsheets of loads of defects. Then I generally create sort of like a master sort of copy of everything that they've put together, and then I sort of sit there and run all them and hope they do it properly and don't produce any errors for me.
Sure. Okay. Yeah. Yeah, it's hard to say without knowing the industry, I guess. To think of, you know, where you can bring skills that you've learned here into it.
Yeah. So obviously I'm not that far. I think I'm just sort of halfway through, a bit further on the web scraper. And obviously what I came up with to begin with is sort of research sites, bidding on projects, that sort of thing, doing research within different companies and pulling research out quicker than what they're doing now. But that's the only thing I've sort of currently come up with. But obviously a few more would be handy.
Yeah.
I think what James is saying is like you need to get all the data in a single source, you know, like in a data warehouse or something, and then that just acts as your source of truth for your domain, you know, and then
Exactly.
you might, from a larger data set from multiple different clients, you might be able to draw bigger insights than you currently are at the moment, and it should just be easier as well, like than dealing with just Excel spreadsheets and 46 different folders. And I think that's the main thing, is like a lot of businesses is just run and live and breathe off Excel, and it's once you just end up with too many spreadsheets, and it's like it really makes sense to just have one centralized location where you can dashboard off it and actually perform analysis on the larger data set overall.
Yeah, that sounds like a plan. This industry actually is probably a bit further back than Excel. There's a lot of written paperwork in filing cabinets sort of sitting.
Wow.
So Excel is like new here.
I get you. So that'll be someone's got to enter that data then, I guess, and then get it in a sort of central source.
Yeah, I mean, the company I work for is also a consultancy company. You know, it's a consultancy company where, you know, we have a data as our core product, and then through our consultants that kind of gets shown to our new clients. And as a consultancy company, I think, you know, one of the biggest selling points for you to pick on a new client is how big is your one source of truth, how much data and how insightful can you bring of analytics can you bring to us. And having a really big data set and being able to kind of compete with other companies out there about that is a big selling point for a consultancy company.
Good question, Damon.
Can I come in?
Yes.
Hi.
Absolutely.
Thanks. Enjoyed the Q&A. It's very insightful, James. Thank you. Thanks for the questions as well. Helped. Just my question around your Microsoft Azure versus Amazon. You talked about businesses perhaps favoring Azure purely because already in the market for Microsoft products. What would you say that you've noticed that which company types or company groups tend to use Amazon? So say for instance that I'm doing stuff on Amazon, I write my CV, I've got Amazon here. So what companies would I generally want to target? Would it be, I don't know, health sector or something?
That's a good question. I can't give you an educated answer. But yeah, I guess maybe companies that maybe already work closer to Amazon anyway. So e-commerce companies maybe. But that's just a guess.
I've actually got an answer for that. So Amazon actually has more customers than Azure. But,
oh well.
Yeah. So actually, last I checked, it's more customers than Azure. But it'd be small, especially startups, because it's pay as you go, pretty much, less contracts. So small to medium businesses, I'd say like that kind of area is where they tend to target. Yeah, big business is just, I think it's like James was saying, it's just down to the fact that those contracts are already in place and they've already been in contact with someone at Microsoft. So, you know, it's easy to sell to them again and they don't want to change. But yeah, small to medium businesses tend to use AWS a lot. Let's see. Hope that helps, Angie.
Another question.
Go for it.
There are CVs. If I was to go and apply for a job, what would you say are the core skill sets I should have that would generally be well accepted, I think, from a data entry perspective, because there's so many technologies out there. You know, you could write Selenium, you could write AWS, but you know, I mean, at the end of the day, when you look in the job market, people want so many different flavors of, well, experience. I'm just thinking, what actually are people looking for that obviously AiCore can't obviously provide?
Yeah, so I think a little segue to that question is that a lot of companies don't know what they want. They don't know what they're looking for, or at least the people who write the job descriptions don't truly understand. So when you apply for a job, sometimes they'll just list all sorts of technologies on there and they really don't have a clue what they're looking for. Specifically for a data engineering job, I think the most important thing is obviously having you know, proficient skills in a coding language. Most common one, most common is probably Python or C++, or maybe a little bit Scala. And then I'd say exposure to cloud services. So having used some kind of cloud storage and kind of worked with the idea of being able to authenticate things and connect different services to the cloud. That's a really useful thing to have exposure to. And then I think truly understanding like the best practices for data frame structures and how to build an efficient database and how to query a database depending on how you've built it in whatever schema it is. Because I'd say querying a database is probably more associated with being a data analyst these days. But being able to, you need to understand how to query a database whilst you're building a schema for a database as well, because you have to understand how someone is going to access, how someone is going to reconstruct a data frame that they want to access. I think those are the main points. I'd say main focus on a programming language, exposure to cloud technologies, whether it be Azure, AWS, or Google, and then understanding how different data frame structures work in practice with different kind of technologies out there, which allow you to transform or display or navigate different data frames.
That's great. Thank you. Thanks, James.
James, I got a question about you're starting to learn Scala. I assume that is because the native language of Spark is Scala, and obviously it runs quicker ultimately. So is that something you've decided to do yourself, or is that something that your kind of company's pushing towards themselves, or was it just you decide to do it for your own?
Yeah, so the company's not pushing towards it. However, we are sitting, data engineering team at the minute at our company, excuse me, are sitting the Azure data engineering certification examination, which involves little pieces of Scala, but also, it's kind of like quite Spark heavy. And Scala just kind of, I think it kind of helps you better understand Spark as a whole when you communicate with it through Scala as opposed to PySpark.
Got you. And how are you finding that process from moving, obviously, Python, like moving over to Scala? Has it been quite painful, or has it been relatively easy? How do you find learning a new language?
It's quite fun because it's quite a different kind of like thought process for tackling different kind of things inside your coding. Like some programming language is quite easy to kind of transfer between because it's mostly just a change of syntax and how you structure different data types. With Scala, is like you kind of go at a problem from a different angle to figure out how to solve it. If you want to transform or join a data frame or something, you go at it from a different angle.
Mm-hmm. Yeah. Cool. Anyone else get any questions at all, guys?
Just one question about your prediction about not needing to code. When do you think that'll happen?
I don't know, but you know, there's a lot involved with data engineering now that doesn't have to involve coding, because so much these data factories that they have on cloud services, which is where you literally just click and drag all the different services you have. They include everything. You know, you can click and drag the process of loading data. You can click and drag the process of transforming data, and even kind of different analytics. You can attach like different kind of machine learning procedures to the end of the pipeline as well. So I mean, it was a bit of a jokey prediction, but I do think there's a possibility that, you know, there's going to be some roles out there where data engineers don't actually perform any kind of transformation from within, you know, from within a notebook or within a Python document or anything like that. It's, you know, you can do a lot of that transformation just from click and drag activities.
What do you think the evolution of a data engineer is then? Because they'll evolve, they'll need to.
Evolution of a data engineer, yeah. Good question.
Maybe we'll start joining systems together, whole systems together instead of picking like smaller pipelines. I don't know. That's DevOps. That's DevOps, really. Yeah,
but I think DevOps is dying personally. I think DevOps is also kind of being absorbed by data engineering.
Yeah. It's
and also, yeah, I think data science and machine learning as well is kind of being absorbed by pre-built packages, by certain programming languages, which can, you know, you could get a pre-built Python package that has some kind of machine learning model in it, which is going to be better than any model which you can make or train yourself, depending on different variables. But yeah, I think data engineers have kind of absorbed the responsibilities of a DevOps role.
Yeah, a lot of overlap, isn't there? Yeah.
Any more questions from anyone?
Okay, we'll wrap it up there, guys. Thanks so much for coming. Thanks to James for giving us his insight.
Yeah, thank you, everyone.
We all enjoyed that.
We did. Thank you.
Brilliant.
Yeah, cheers, James.
No worries. Have a great evening, everyone.
Enjoy, guys.
Cheers.
Okay, I'll upload this
Thank you, James.
tonight for everyone.